Hey, what's going on, everybody? It's David. Coming back at you with another CS50 help walkthrough video. This one is for Speller. So, Speller, they give you a dictionary file or a text file that's full of just different words. We're going to load up a table of linked lists. Some call those dictionaries, hash tables, and then we're going to get past a bunch of words. We're going to see if those words are inside the table or keeping track of. So along that way, you can do some hashing, make things more efficient. I kind of took a really low level kind of thing. I shouldn't say low level. I was really lazy on this assignment. So one, because I am just a lazy person, but also two, because there's a lot of efficiency that you could gain. In this assignment, you can actually kind of rank, see how you did against other people. So instead of doing something, I don't know, pulling all these crazy algorithms or something, I just wanted to do the bare minimum. So if you all are having problems with it, you can get it working, but then also still have, a way to improve. I did that. So basically, the thing you're going to do is you use a hash function here, and that hash is going to be dependent on what hashing function you use to find that hash or key for your table. So we'll kind of get into this, but basically I just went through the word, I changed every letter they gave me to lowercase, and then at the end I used the modulus operator against n, and in my case n is 26. Why is it 26? Because there's 26 letters in the alphabet. That's really it. I didn't really think that much into it. The walkthroughs recommend kind of Googling around, looking for really cool hashing functions, and I definitely recommend that. There's some really cool ones out there. I took the easy way out. I just thought that I would just bucket them up based on letter, which doesn't really make sense because this is not based on letter. But that's just how I did it. So we're going to go with that. Definitely feel free to improve upon that. So I kind of started out already. I wanted to get all these libraries in there that I need to know for this thing. So we're going to be strings is needed. The walkthrough videos recommend using string case compare, which compares the strings with irregardless of case. So I pulled that in. I brought in string because we work a lot with strings here. Standard def, stdio, the basic ones. C-type because I wanted to use the isLower function that we used in the past instead of creating my own. Standard lib and standard bool. So you'll see these things a lot. So kind of walking through what they did here in the code was they created this structure called the node. And this node has a word and then a pointer to the next node. And then they give us a table of nodes. So that's going to be kind of what I drew here. Sorry, never mind all my scratch stuff. But basically, wait, can I actually do this? Oh, I can. Cool. Too far. So me putting 26 there, it's going to create a table like this. With the idea being is, as we get a word, I'm going to put it into whichever row it belongs. And the way I find that row it belongs is here based on this key that I find from this mathematical function. So that's what I did. I'm sure there's better ways. But instead of having one bucket, I'm going to have 26. So those are the only changes I've made so far to this. And let's get started. So the first thing I did was I actually want to start on load. So the load is where they pass in a file name. We're going to open that and then scan in every word from there and put it into our table. So I'm actually going to go ahead and change this to true, just because we're working on it. Yeah, so they actually pass in, they have like a bunch of different dictionaries. Oh, that was the wrong one. So that's kind of what we're going to be reading in. But start this off with, we're going to use a file pointer because they're passing us in a file. what they're passing in is actually this. So a file that we're going to have to read. So I'm just going to call it file pointer. And this is going to be fopen, that dictionary they pass in, and we want to set it to read. And then, excuse me, I drank way too much coffee. Based on other assignments, you kind of know that if fopen fails, this is going to come back null. So before we actually operate on that, I want to check to see if it's null. So I'm just going to say file pointer. I'm actually going to say if first, because that's how if statements work. So if file pointer equals null, that's when I want to return that false, because this failed. Don't pass go, just give up, don't collect $200. And then, so if we made it this far, we're going to need a table to store what they pass in. So this is where I'm actually going to initialize that table that we had earlier. I'm going to say int equals I, int is less than int, I plus plus. And then in here, int I equals null. Null. So just kind of zeroizing out everything there. And because we are reading from a file, instead of just putting that directly into my table, I want to store that somewhere. So this is the case where I'm going to make this this temp word, and I'm just going to make it equal to length plus 1. The reason I choose that is because that is what the word in this node uses, length plus 1. If you're interested to see what length is, that's going to be over here. I think it's, equal to 45. So I'm assuming the biggest word they're going to pass in is 45, and the plus 1 is a null terminator, but I don't care enough to actually read the dictionaries. So I'm just going to go with what they gave me. So this temp word is where I'm going to, when I read out from the dictionary, that's where I'm going to put it. So this is what I'm going to do. In the walkthroughs, they recommend an fscanf, which is a scanf, or I think kind of like the CS50 uses getString. GetString is just a function that kind of wraps scanf. So fscanf is scanf, but for files. So I'm going to use fscanf. If you're interested, that's over here in this programmer manual. You all are pretty smart. I'm sure you can figure it out. But that's where you can go if you can't find it. So while file pointer, and while I can scan from it, and the format it comes in is string in the new line. And then I want to load this into temp word. And what they really hint at in the walkthrough is this doesn't equal EOF, which is end of file. So I think they actually give you this in the walkthrough, or they really strongly hint at scanf until you see an EOF. So that's how you'd syntactically do that. You can just find that out by Googling. So while I'm here, we want to put this word into our table. And our table is of type node. And here we have the definition for a node. So basically, I'm going to create a temporary node, and I'm going to load this word with the word from the dictionary, and then I'm going to put this node into our table. And then I'm going to set this next equal to null, but when I add new stuff to it, I'm going to be changing the next. So knowing that we're going to be working with that, I want to create this node type, and I'm just going to call it temp here. We can call it temp node if you want. And this is important here, is we actually need to use malloc. So the reason we need to use malloc is because we are taking this node, putting it in this table, and then storing it in memory. It could be over here, over here, over here. I don't know, hard disk RAM. I don't know, but we need to store it somewhere. So I'm going to let the computer figure it out by asking for memory in malloc and then using that to store this. So this is important here because we're going to want to call upon that memory later in different functions. And because it's in a different function, it's going to be out of scope. So that's why we need to ask for memory, put our node into memory, and then store it. So later we can go request that node from the memory. So if you see me malloc here, that's why. And then later we'll go back and make sure to free that, because anything you malloc, you have to free. Anyways, we're not worried about that right now. Right now we just did this. And then we want to take the word that we moved in here and put it onto this node that we just made. So for that, I'm going to use string copy. I think that's it, yeah, string copy. And I want to say temp node. And off of that, I want the word, and I want to load it with temp word. So this word here equals this, and we can do that because the word here is length plus 1, and our temp word is length plus 1, so we always know it's going to fit. So we string compared, we put that onto our temp node, and now we want to find the hash of it. So while we'll go over to the hash later, we want to find the hash of temp word. In that hash, I'm going to say it's a key, because that's going to be the key in our table. So if you think of a table as a key value pair, where you search for this key and then it gives you the associated value, that hash is going to give us the key that we use in the table. So now that we have the key, we want to load the table. And there's two different things we want to think about when we load the table. One, if there's no value there already. And then two, if there exists a value. If there is no value there already, we just put it there in that spot. So let's do that first. So if, what I call table key, if this equals null, so if there's nothing there, I want table key to equal temp node. And then I want, actually wait, I think I had this backwards. I want temp node next to equal null. And I want table key to equal temp node. Cool. So we took this structure that we have. We're saying, hey, there's nothing next. Sorry. So we did that by setting this next equal to null. And then we just put it on that table where we found that key. So if this key turns out to be 1, I can't find my mouse. If this key turns out to be 1, like here, we're just going to create this node here. So instead of this, we're now going to be temp node. Cool. So now that kind of brings us to the next part, is what if a node is already there? So that brings us down to the else. So if that node is already there, there's a couple ways you can do this. Is we're going to find that hash still. We have that hash, or the key, so we're going to figure out which key this belongs to. If something's already there, like let's say we get another 1, and there's a temp node here. One way would be to cycle through this list and put it in on the end. That's probably like the better way to do it. I'm going to kind of cheat, and I'm instead going to put this node here in first and then just make it link to what's next. So instead of putting it on the end, I'm going to put it right here. And then I'm going to set next equal to that temp node. This is horrible. Absolutely horrible. Yeah. Okay. So that's just it. I'm just going to put it in first. So the way I'm going to do that is I'm going to set temp node next equal to the table key that we're currently on. And so that's going to be the very first node on that key, on that level. That's what I'm going to point to. And then I'm going to take the table key and set it equal to temp node. So instead of putting it at the end, I'm just placing it right there in the front. And then I'm going to close the file that we opened. So up here we have file pointer, and I want to close it because all pointers you want to close, all malloc memory you want to free. Cool. So I think that is all there is to load. Looks like I messed something up. No, it looks like I messed a lot up. Wow. Char, but type node. Temp node. Oh shoot, I'm sorry. This should be, that's an array, so that's going to be temp node, not a. I'm sorry, temp word. So that's going to be a character array, not a node. So it looks like I saw something messed up. String compare temp node word with temp word. Ignore return value declared with. So 61. I actually don't know what's going on. String compare node word temp word. Ignoring return value of function declared with. Oh, because this says compare and I want copy. Because we aren't comparing anything, we are just copying it over. Make. Cool, it passed that time. Let's check it. Hopefully it just doesn't blow up. That's mostly what I'm wanting here. Oh man. Man, I keep trying to like build it and set it, that way it doesn't forget my GitHub stuff. I don't know what kind of timer it's on, but I always mess it up. So anyways, let's go and compare. I think we passed a couple tests. And while this is going on, I'm actually going to do a function here. Next up, I'm going to do size. And I'm going to kind of, not say cheat, because they suggest this, but I'm going to take the easy way out. I think the academic way would be to read each level on your table. So each hash, each key, and we know I have 26, so I'd make a for loop that through each level, I would then increment through each thing stored on that level and free it. Or I'm sorry, to count it up. And at the end, I'd return how many that pulls out. You could do that, probably a better way to do it. I'm going to be lazy, and I know that here in load, we're iterating through each word. So instead of recounting it here, I'm just going to count it once here and store it. I'm going to do that by creating a global variable. I don't normally suggest global variables, but I think in this case it kind of makes sense. So I'm going to set word count equal to 0. And then here, while at the very end of, before it goes and grabs another word, I'm just going to increment word count. And then here, instead of return 0, I'm going to have it return word count. Cool. So that should be it for the size. I'm going to go ahead and kind of check that in. Make sure I didn't misspell anything. Word count, word count, word count. Cool. So we have load done, and we have size done. Let's knock out hash. So this is kind of how we talked about earlier. This is where like most of the algorithm stuff is going to be done in your code. This is where probably a lot of your efficiencies can be found. But basically, I want to create a value. So this is 0. And then I want to increment through each letter there. I think I actually drew it out. Increment through each letter to lower it, and then use the modulo command with our n. So I'm going to do that here. So for int equals I, because dealing with this pointer thing is kind of weird, instead of saying like string length of word, I'm just going to say while word I doesn't equal the null terminator. I want a plus plus. And then here, I want to lower this word I. And I wanted to lower it that way. If you pass in hello in all caps, I still compare it to the hello in all lowercase in the dictionary. So you could also use like two-upper or something. I don't know, too lower just makes sense to me. And so that's going to add up all the ones, and then here, instead of returning 0, I'm actually going to return the value, and then minus n, which is our 26. And that's it. That's our hash. The walkthrough recommends kind of Googling and looking for more efficient hashes, and I think that's awesome. There's actually some really cool math that's done with like finding prime numbers because you get better hash values, or doing like bitwise arithmetic. It's kind of down the rabbit hole, but I kind of recommend it if you're into that kind of thing. If you're hoping just to, work on C syntax or learn how to code, and you're not interested in the math behind it. I don't know. I still think it's interesting, but you do you, man, or woman. You do you. You do you. Okay, check. So check here is they pass in a word. We want to see if that word exists in our table. So the way we're going to do that is kind of how we load it, or when we use this load function, we created this temporary node to go through our table. We're going to pretty much do the same thing, but we don't need to malloc it because it only exists in the scope. So here, I'm going to create a temporary node. So node pointer, and I'm going to take that back. I am going to do that, but I'm not going to do that yet. We want to find the key of what is being passed in. So I can do that by key equals hash word. So we're going to hash this word they passed in so we get that key so we know which row to check this on. So now I'm going to say this is where our node pointer is going to come in now. And I'm going to set it to that table I. So if they pass in a 1, or something that hashes to a 1, I'm going to set my node right here, my node pointer. And then I'm going to increment through everything on this line and do a string compare against it. So we're here, and I want to say while basically node pointer doesn't equal null, type it, doesn't equal null, I think they recommend using string case compare to make sure that the letters don't matter. So if, and I wrote this down of how to spell it because I'd never actually used that before this assignment. But so if node point, then we want to compare the word that we're currently on and the word passed in. And the way this function works is if it returns a 0, that means they have the same word. So if it returns a 0, right here we want to return false. If not, I want to go down to the next word on this list. So to do that using pointers, I want to do node pointer equals node pointer next. Cool. So hash the word, set a pointer, go through that hash, compare every word in that hash, which is why kind of bigger hashers are nice. Your memory usage is going to go up because your table's a lot larger, but your efficiency of grabbing words out is going to be lower. It's going to be better. So if it's not in there, I want to return false. So I'm going to build this, and it doesn't work. Table I. I think that's because I want the key on that table and not an I. Cool. Okay. So we've done check now, we've done hash, we've done load, we've done size. So the actual functionality of this code is done. What we're not doing is we're not freeing up our stuff, which is super important. So let's do that. this return false, I don't actually think if this function runs and there's no error, this shouldn't return false. So I'm going to return true here. And kind of how I kind of talked on it when finding size is I want to increment through every level and every possible thing in that level and just free them. So the way I'm going to do this is int, I'm going to make a for loop to go through each level. So int equals I is less than n, I plus plus. And I actually want to be in that for loop. And I'm going to create a node pointer, kind of how we did earlier. So node pointer, and I'm going to set that equal to that current row. And then while, there's like fireworks going off, I don't know if you can hear it. Happy 4th of July if you're American. Happy, hopefully your country has some sort of form of Independence Day and it's a celebration because, you all should celebrate that. Node pointer, so while this doesn't equal null, I want to keep going down here. And what I want to do is, if I'm here, if I'm on temp node and there's something over here, I can't just free temp node 1 there. I have to have something point at this and then move over here before I free it, or else I'm just going to free what I'm currently on. So the way I do that is I'm just going to make another node pointer. It's called delete me. This is going to equal node pointer. Node pointer is going to equal node pointer next. So it keeps going down the line. And then here I'm going to free delete me. Cool. And then at the very end of this, I want to null out that table. And then we return true. And I think that's it. Let's find out. So I'm going to make... Okay, line 124. So expression, result unused. Oh, because I'm not nulling this. Cool. Make. I null these be all caps. Let's try it one more time. Okay. I've got a good feeling about this. It just wasn't as bad as I thought. I thought this homework was going to be like a lot longer. I think once you get like the logic idea down what you want to do, it's easy to put out there. Now, if you wanted something like super efficient, it'd probably take a lot more time. Like if you want to place on like the high scores or something, you're definitely going to want to do better. But cool. So we take in the file they want. We load our table with it. We created a hash function to figure out what hash it goes at. We created a check function to check if what they pass in is in our table. We created a size function to return however many words we're keeping track of. And we created an unload function to make sure that we are freeing up all the memory to come to. And that passes all the tests. So thanks for joining me. Hopefully you learned a lot. That's Speller. Until next time.